Hi everybody, welcome back. I hope you had a nice spring break. Today's lesson is on the topic of Hess's Law, Hess Law. We're still on the thermochemistry unit, and this is something I think you'll kind of enjoy. It's fun. So, Hess's Law, the theory, and hopefully you're copying these notes. I think it really helps. So, the delta H for some compounds is not in our table, since not all compounds are always made from their elements. So we use Hess's law. So, for example, the examples you should have copied. In this equation, we're forming nitrogen dioxide, and we want to find the delta H. Last week, we would just look on this table and go, okay, well, nitrogen dioxide, its delta H is 33.1. We can't do that with this equation. Hopefully you can recognize why, some of you smart people. Okay, because this nitrogen dioxide is not formed from its elements. Okay, all the delta H's on this table are when compounds are formed from their elements. That delta H for NO2 is this equation. We're forming nitrogen dioxide from N2 and O2 make NO2. So that's the delta H because this is formed from its elements. In this example, the nitrogen dioxide is made from a NO plus O2. This is a compound and an element. So it's not going to be the same exact delta H. We need to do Hess's law to figure out the delta H. So the theory is delta H's, you can add them together, you can add up equations and add delta H's. I will be going through these 5 steps, and here it goes. First step says to write the balanced equation for all compounds in the reaction, not just elements, compounds. So in this equation, and I like to circle them. I like to go, NO, that's a compound. O2 is an element, and NO2, that's a compound. So I need to write the formation equation for that and that, which is what we had learned before we went to spring break. So the formation for NO is like this. N2 plus O2 make NO. Now I got to balance it. This is 1/2 N2. 1/2 O2. And remember, those are diatomics, so that's N2 and O2. And I have to cut them in half for balance. The other compound is NO2, so the formation equation for that is going to be 1/2 N2 plus O2 make NO2. All right, that's step 1, right? The formation equation for the compounds in the reaction. Step 2, find the delta H formation from the table and write it next to each equation. So because these are formed from their elements, I can find their delta H's on this chart. So if I look up nitrogen monoxide NO, its delta H is 90.3, and NO2, its delta H is 33.1, and those are both positive. And for this, I'm just writing it on this, just next to the equation. I'm going to make a little column that says delta H. I don't have to put it in the equation. I'm just writing the equations and listing the delta H formations for each of those next to that equation. Step 3 is the big step. It says adjust equations so that by adding them together, they equal the desired reaction. The desired reaction is this original given reaction. This thing is my desired reaction. Okay, I'm going to add these together so that they look like that. And you might have to adjust them. So what that means is compounds, so subset A, compounds should be on the same side of the arrow as they are in the desired reaction. If they're not, flip the equation and change the sign of delta H. So for example, in this first equation, I've written it, my NO is on the right side of the arrow. In my desired reaction, the NO is on the left side of the arrow. So I'm going to have to take this equation and flip it, just flip it, so that that NO is on the left side because that's how it is in my desired reaction. So I'm going to write flip, and I just flip the whole equation. I go NO goes into 1/2 N2 plus 1/2 O2. Okay. And it says flip the equation and change the sign of delta H. So I'm still keeping track of delta H right over here. Since I flipped the equation, the delta H is now negative 90.3. If you flip it, the sign of delta H changes. The second equation, and that one's fine. Second equation, NO2 is on the right side. The way I've written it, NO2 is on the right side. So that one I just keep. I don't do anything. I'm just going to keep it, but I'm going to rewrite it over here. 1/2 N2 plus O2 makes NO2. And I didn't do anything to the equation, so the delta H just stays positive 33.1. Part B said if the compounds in the desired reaction have coefficients, multiply it. We don't need to do that for this one because there are no coefficients on my compounds. So step 4 says add up your desired reactions to see if the result looks like the desired reaction. Same sides on opposite sides cancel, same chemicals on same side add together. So that means this, and I do want you to show this. One of the important things here, since you're not in class, is that you're showing your work. I want you to show me how things add up or cancel. For example, I have NO on the left side of the arrow. On the right side, I don't have any NOs, so that does not cancel. But on the left side, I have 1/2 of an N2 here, and I have 1/2 of an N2 over on the right side of that one. So those cancel because they're the same thing on opposite sides of the arrow. On the left side, I have a whole oxygen, 1 O2, and I have 1/2 of an oxygen over here. So now we have partial cancellation. This 1/2 O2 goes away, and it leaves me with 1/2 of an O2 on this side. Okay, this NO2 on the right, there is no NO2 on the left to cancel it, so I'm just going to leave it. So I've canceled everything that can cancel. Now I'm going to add up all the things on the left side of the arrow, all these reactants. What's left over? I have NO and 1/2 of an O2. So I write this, NO plus 1/2 O2 make, and what's left on the right side? Just this NO2. Does that look like my desired reaction? Yes. So that means I did everything correctly. And so step 5 is just to add up the delta H's. So I'm just going to add those together. Negative 90.3 plus 33.1 is negative 57.2 kilojoules. And that's my answer. I did all this work just to get that delta H. Aren't those fun? Okay, let's try this one together. First step, write the balanced formation equation for all of the compounds in this reaction. So look through the equation. Which ones are compounds? Not Mg, that's an element. SiCl4, that's a compound. That's an element. This is a compound, MgCl2. Now it has a coefficient, but don't circle that. We'll deal with the coefficient in step 3. That's if they have coefficients. So don't worry. The first step, just write the formation equation for the compounds. So again, like last week, SiCl4, that's made of Si, silicon. Not diatomic, so just Si. Chlorine is Cl. Now that is a diatomic, so I have to put Cl2. We're forming it from its elements. Make SiCl4. Now it's not quite balanced. I need to put a 2 in front of the Cl2 to balance the SiCl4. Remember, on the left side, you're forming it just from its elements. The only subscript you put on the left side is a 2 if it's one of the diatomics. So that's that compound. This compound, MgCl2, well, that's made of Mg, not diatomic, plus chlorine, which is a diatomic, so I put the 2 there, make MgCl2. Again, do not worry about the 2 in front of it yet. We're just writing the formation equation for the compounds. Look up the delta H's on your chart and write those next to it. So silicon tetrachloride, negative 687.01. Magnesium chloride, negative 641.6. So we're writing the delta, we're keeping a little column of the delta H's right next to it. That was step 2. Refer to your steps if you're ever stuck. Step 3 is to adjust the equation. So when we add them together, it looks like this, desired reaction. So let's look at this first equation. What do we have to do to that? Well, the way we wrote it, it's on the right side of the arrow. In my desired reaction, SiCl4 is on the left side of the arrow. So this is one where I need to flip it. So you write the word flip so that I know that you flipped it. And that's, again, for full credit on these, please do this. Flip it over. I'm just going to reverse the equation. SiCl4 turns into Si plus 2 Cl2s. Because I flipped it, the delta H, I changed the sign of it. It is now positive 687.01. The MgCl2, okay, the way I wrote it, it's on the right side of the arrow. In my desired reaction, it's on the right side of the arrow, so I don't need to flip this. But now we deal with that coefficient. In our desired reaction, it has a 2 in front of it. So on our notes, it said, if compounds in the desired reaction have coefficients, multiply the entire formation equation by that number, even the delta H. So we're going to times this entire equation by 2. Everything. Okay? So I'm going to have to distribute, remember math, 2 magnesiums plus 2 chlorines make 2 MgCl2s. And the delta H, 641.6 times 2 is, it was negative, so keep it negative. Negative 1283.2.